going on, guys? In this video we are going to see how to compute the Laplace transform of 1, and also we are going to see how to compute the Laplace transform of t square. Now let's start with 1. Now let me separate this one first before we go ahead and do that. Let's separate like this, and here we are going to start with this one right here, Laplace transform of 1. Whenever we have here f of t is the function is whatever the thing that's inside of this curly bracket. In this case that's 1 right here. And Laplace transform, when we do the Laplace transform of anything, f of t, generally if we say f of t, the Laplace transform equation is like this: integral go from 0 to infinity e power negative st, then f of t dt. All we have to do is plug the function right here and do the integration. If we do the integration, that's going to give us the Laplace transform. In our case, f of t is 1. That's given right here. Whenever we have a curly bracket, we have to look at what is inside of this. Here it's 1, so we can put it right here instead of f of t. This is 0 to infinity e power negative st. Instead of f of t, we put 1 right here, dt. Now we have to do the integration. If we do the integration, but before we do, since we have improper integral, what we do is we take the limit b approach to infinity, and then instead of this infinity we put b right here. Integral go from 0 to b e power negative st dt. Okay, if we integrate negative st dt, that's going to be just e power negative st and divided by negative s. So we can just take the negative in front. Okay, let's erase this equal sign and let's put it right here. Okay, equal sign right here and negative in front, and the s remain in the denominator. Okay, now we have integrated this one. This is going from 0 to b, and b goes to infinity. Okay, now this is the integration. Now after this we have to just substitute this b and 0 and see what we get. So first let's substitute b, e power negative s. Since we are integrating with respect to t, here the t will be replaced with b. Okay, so this one is going to be sb, and then denominator remain the same. So we just substituted b first, then we have to substitute. Okay, let me put a bracket right here. Then we have to substitute 0 minus negative e power s times 0 divided by s. Okay, now after we substitute infinity, like b goes to infinity, right? So we have to substitute infinity for b. Since we can also write this one as minus 1 over e power s e power sb, and minus here it's going to be minus, and this is going to be just e power 0, that's 1 over s. And here if we substitute infinity for b, this is going to be just 0, because e power infinity, that's a big number in the denominator, so the first term is going to be 0. Minus that's going to be plus 1 over s. So finally we will get 1 over s. So final answer is f of s is equal to 1 over s. That's the Laplace transform of 1. Now let's look at this one. Compute Laplace transform of t square. Same equation. So whenever we have a Laplace transform of a function, the generic equation is 0 to infinity e power negative st f of t dt. And after that, instead of this f of t, we put this function. So this is going to be 0 to infinity e power negative st. Instead of this function, we put t square right here, dt. Now here we had to do some tricks because we are having e power negative st t square. So we can do the integration by parts. Here we had to use our u and dv for that. Let's use u as t square and dv as e power negative st. I took this one for u, so the remaining is dv, e power negative st dt. And you know that integration by part is integration of u dv is u dv is equivalent to uv minus integration of v du. So after you use and integrate this one, you are going to get this one. You are going to get minus t square divided by s e power negative st minus 2t over s square e power negative st minus 2 over s cube e power negative st, and going from 0 to b. Okay, now first we are going to substitute b for the t terms. So this is going to become negative b square over s. Instead of all the t, we are going to substitute b, and if it's negative, we can move it to the denominator. So this is going to be e power sb right here minus 2b over s square e power sb minus 2 over s cube e power sb. Now this is for when we substitute b, then we are going to substitute 0. So minus, if we substitute 0 for this term, the first one is going to be just 0, because since we have 0 here, it's going to be just 0 minus this is also 0. The third term remains like 2 over s cube times e power negative s times 0. That's going to be just 0. Okay, I substitute b and 0. Now here you can see we are going to substitute infinity for, because b goes to infinity, so we had to substitute infinity for the b terms. Here you can see we have infinity over infinity kind of situation. But whenever you have exponential, if you see exponential in the denominator and e power infinity in the denominator, it's going to be definitely 0, because exponentials always grows faster than the normal things, quadratic or anything. So we can directly say that, but you can also use the L'Hopital rule. If you use the L'Hopital rule, this is also infinity over infinity, because since we have b over b, this is also infinity over infinity. So when you do the L'Hopital rule, when you take the derivative, you will get this one, and after you take the derivative, you will get this one. And if you look at this one, here we have 2 over s cube e power sb, and if you substitute infinity for this b, this is going to be definitely 0, because we have e power infinity in the denominator, so this is going to be 0. So it means this is 0, this is 0, this is 0, so the whole thing is 0. So 0 minus, and here we have minus, we put the minus already, and here we have minus e power 0, negative 0 is just 1, negative 0 is, we can just put it as 0, e power 0 is just 1, and the 2 power s cube remains the same. And finally we will end up minus minus become plus, so we will end up with 2 over s cube. And here we have to have one more condition, this s has to be a positive number, because if the s is negative, then it will go up again. So the condition is s has to be positive, greater than 0, and for here also, the previous one also, s has to be greater than 0, which has to be a positive number, and here also s has to be greater than 0, and this is the answer. So for this one, we can say f of s is equal to 2 over s cube, and that's the Laplace transform of t square, and that's how we do that. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equations, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.